Hello. Yeah, easy for you to say. It looks a lot better here than it does in my little MetaGuide program. Say something. I can't hear you.
Sorry, I had the microphone turned off. So, all right, are you ready? Should I push this
Sure.
one?
Go ahead. I think it looks all right.
I think it looks fantastic.
This is my backup equipment.
All right.
I'll move it up to the top a little bit here. I'm not used to seeing it in color either.
All right, so we're live now.
Sweet.
So just in case you perhaps have loud children in the background.
That's the beautiful thing about the night sky is the kids are usually asleep and it's quiet.
All right. Let me,
I have gotten my kids involved as much as I can. I try not to push my hobby on them. Try to let them make their own way. But they show interest time and again, and it's kind of fun.
okay.
Remember which direction is which now. So I believe this is an inverted image again.
Is that?
I know the North Equatorial Belt. We need like annotations on here. The North Equatorial Belt is the skinnier of the two belts in the middle, and the South Equatorial Belt is the brown belt on the upper part there, and it's a little thicker and fatter in latitude.
And so which telescope are we looking at right now?
So this is the 8-inch F10 Schmidt-Cassegrain, and it's a Celestron, the special edition one. And I have a 2.5x TeleVue PowerMate inserted in. I forget, it's probably about I think it's right around F25 or F26, something like that.
And then what are you using to bring in the video?
The video comes off of believe it or not, a Cisco webcam. It's called the Video Telephony Advantage, and it's very similar to the Logitech 3000 or 4000 series. So it's just a 640 by 480 RGB color webcam.
I can definitely see the northern and southern bands. I can see some of the clouds along the bottom.
Yes, so, and this is always a good refresher for me, too. The brown areas are belts, and the white areas are zones. And with the northern part of the planet is actually at the bottom of the screen.
How come we can't see any of the moons?
They're there. They're off to the left and the right, probably because of the magnification.
Oh, so they're just...
Feel brave.
I'll
venture off to the side here, see what we can find. I did see them at a lower magnification. Let's try the other side here. I don't want it to drift too far.
You don't want to lose it. How hard?
This is how you know it's a live view, right? Because I tell it to move and it moves, right?
Yeah. How difficult was it for you to align it?
It wasn't too bad, right? So the actual reason I bought this telescope was because it was small, light, portable, and yet still powerful. And I liked having that kind of balance of it. So it's kind of I kept it even though I have a bigger scope because it's I won't say it's my throw-around telescope, but there's something to be able to just grab it and move it around. Now, when I do that, because it doesn't have a permanent location, it's just sitting on tripod legs. The first thing you got to do is level the tripod legs. So there's a tiny little bubble level, so like a 2-axis bubble level on the wedge portion of it, and that helps get the alt and azimuth axes in the proper alignment to Earth's rotation. And then it's just a matter of using the hand controller software to get it moving in the right direction. You get it latitude, longitude, date, time, and then pretty much after that you just say, hey, here's 1 or 2 stars, and Celestron's magic figures the rest out for you. This is pretty cool.
Right. And so how hard do you think it would be to find other stuff? Like, obviously we could look at this all day.
Yeah, we could try. Let's do this first. Let's pop the power mate out. We're going to move around a lot. Probably want to lower the... We'll see the moons here while we do this.
All right, so we've got some people here are kind of wondering what it is or what's going on. So Eric Hampshire wants to know what kind of a telescope it is, and it's your 8-inch Celestron, right?
Yes, it's a Schmidt-Cassegrain. Where did it go?
Uh-oh.
I see. We are out of focus.
Did it just drift out of view?
No, it's there. You can see the donut. So you can tell it's a compound telescope as it comes in here because it has a hole in the center there. So when you have an out-of-focus star or an out-of-focus object like this, the central obstruction, which is actually the secondary mirror, creates this little diffraction pattern here, and it leaves a big hole in the center. But when it comes into focus, and this is going to be way overexposed, it disappears, right? And there's one of the moons off in the lower left-hand corner there. We can try to move that up into the field of view here. There's one.
There it is. Yeah, I see it.
And so by removing the power mate, I reduced the magnification that the webcam sees. So now it's down to, I don't know, an F10. I think it's 2,000 millimeter focal length, so it's an F10 now.
Right. But as you said, it's a little overexposed now. Right?
Yeah, and I don't know how to change the settings in the Google Hangout. I think I actually have to drop into a software program that allows me to change it because right now Google Hangouts is controlling the camera. So to regain control of the camera and change the exposure settings. There's probably a fancier way to do this with some extra software that I don't have installed right now. Looking for another moon off to the right here. I don't know if I saw one or not.
There it is.
You see another one? Oh yeah, look at that. Oh, that's probably Ganymede because it's pretty bright.
Yeah. So for those of you who are kind of wondering what happened, we had a higher power version. We'll probably switch back to that in a second, but we wanted to see if we could see some of the moons. So that's probably Ganymede off the left, which is pretty bright. Ganymede is the biggest moon in the solar system. And then Titan is the second biggest. Yeah. And actually, astronomers weren't sure for a while there which one was bigger because Titan has a really thick atmosphere, and so we thought that maybe Titan was actually bigger than Ganymede, but now we know better.
If you're real steady, and this is fairly average atmospheric conditions right now, at least by my eye, you can sort of make out that it has a disk, right? It's not just a pinpoint of light. And then, of course, I open my mouth up and all this hot air goes in front of the telescope, right? That's what my wife said.
Yeah.
You want to go back to the large?
Yeah, let's go back to the other one. Matt says Google needs to add live chat to these instead of comments. I agree. That would be a lot better. Yeah, because right now what you have to do is you have to keep reloading the page to see. Yeah, so it's not super ideal.
I'm going to recenter it here because I know I'm going to reduce my field of view as soon as I put that power mate back in.
Yeah.
One of the things that I'm an imager at heart, and one of the things I picked up was a monochrome camera with a color filter wheel, which is how a lot of people take planetary photos. And I got lucky because one of the positions in the color filter wheel is actually a visual diagonal, so if I ever get lost, I don't have to remove the whole unit to find where I am again. I can change to that position, and then I can see with the imaging train intact where I need to be, not where I was. But
now your telescope is a 14-inch, is that right?
yes,
Yeah.
and one of these nights when I'm more motivated, and believe it or not, this Fraser gets me motivated.
Yeah.
One of the nights when I'm a little more motivated, I'll get that one set up. There's a lot of haze out right now, so I kind of was hedging my bets against it.
Now, have you still got a view of the moon right now?
Yeah, I do, actually. It's almost,
Yeah, so
I don't get overhead here. I'm at 35 degrees north latitude, but it's fairly high up there, right on the meridian.
Views of the moon you were showing me before were just stunning. So.
We'll keep this power made in, and we'll slow over to the moon in a minute here. Let's see. I might have to go back there. I don't know which direction I need to go to get this focused here. I see a faint ringing right now. I may have just missed the chip. I'm not sure. Focus, please. Is it coming in? Something's coming in. There it is. See, so it always pays not to get frustrated, because the focal difference between different eyepieces or camera adapters and settings and things like that can be significant.
Yeah.
So you got to have an eye for what an out-of-focus object looks like, especially on a compound telescope.
Yeah, but I mean, this is a phenomenal, I mean, this is a really good example. I mean, an 8-inch telescope like this, these are run about $1,000, $1,200 a telescope like yours?
Yeah.
Yeah. But look at that. Look at that. That's amazing. So, I mean, it's definitely not the Hubble Space Telescope.
But I tell you what, I'll tell you the story. I think you and I were talking maybe a week or so ago. When I got this telescope in 2005, I got it for the Mars opposition, and like I said, I got an 8-inch telescope for portability and power. It was a good mix of both, right? And I couldn't see with my eye through any of the eyepieces that I had the views that I thought I should be able to see in an 8-inch telescope. And when you do enough research, it turns out that the reason the pictures online look so nice is because cameras are much more sensitive than the human eye, and because you can take real high frame rates with these new webcams and video cameras, you get lots and lots of frames, and so you can take the best of those frames, sort out the top 20% or 50% or however many frames you can gather, and throw the rest away that are bad, right? So in moments of good seeing, you keep those good frames, and in the moments of bad seeing, you throw the bad ones away.
And I think
you use a stacking program to average out the differences, and it really takes the whole image and crisps it up. So now, the thing was that it looks really good just in this little eye view here, but if you actually use a different camera that had better sensitivity and did some of those things to it, it would actually look that much better. And
yeah.
I can provide there's probably some sample, if you circle me, there's some sample photos I have that I keep on my Google Plus pages and various trinkets across the internet.
Yeah, and I think people can see, though, I mean, even like when you're watching this video, you can see how the atmospheric distortion, makes Jupiter kind of do this, right? And you can imagine, every now and then you're like, oh, that's a good one, right? And you see just for a second there that things look a little bit clearer. You can see some of the darker bands that are at the poles of the planet. And so that's what the really good astrophotographers do. They use a setup very similar to this. They take a webcam, but a sort of a nicer, a very sort of very specific kind of webcam, and what's called a 2-cam, and they'll put it right onto the eyepiece of their telescope, and then they'll just let it run for bursts of 30 seconds and then they'll take all of those images and they'll look at them frame by frame and go, that's a good one, that's a bad one, that's a good one, that's a bad one. And then when they've got a big collection of these frames, they'll stack them up and try to make a single image that is a stacking of all of the best pieces of all of these stacked up images. So that's why they look really, really nice. There's some really phenomenal astrophotographers out there. There's two that I've been trying to get involved in this project. One is a guy named John Chumak, which you can Google search his name and you'll see some of his photography, and it's just amazing. And another guy named Mike Salway, who he runs a forum called Ice in Space, and both of them are just phenomenal planetary observers. I mean, when you see some of their photos, you would swear it was like the Hubble Space Telescope. They're just phenomenal. And what's amazing is, in many cases, the telescopes that they use are not a lot bigger than what Mike is using here. It's all in the technique, it's all in the software, it's all in patience and good seeing and dark skies and such. So, yeah, that's really amazing. So again, this is our experiment. The cool thing about this with Google Plus, of course, is that we could theoretically, we could put another telescope in, queued up all at the same time. So we could try and get 2, 3, 4, 5 telescopes from different astronomers all pointing at different things. If you want to try, I don't know if people are, want to see the moon, because the moon just
Yeah, I lost my my spot. It has a little bit of a jump in my declination motor still, so
yeah.
so I lost it. So we'll go over to the moon.
Okay.
It's a good segue.
And eventually, if we're really lucky, we can just start taking requests.
There you go.
Someone says Uranus is up. Can we go for that? No.
That's a tough one, actually. Not for the faint of heart, I'll say that. Okay. Ooh, let's see how close I got this.
Are you getting cold out there? A little cold?
I got it's only like 40 degrees here tonight. 45 maybe. So I got my down jacket on. It's actually too warm in the down jacket. All right. So I hit the hand controller and told it to go to the moon. So that was the telescope moving by itself. And I got it. Look how close I got it. Look at that.
That's good.
See it?
Now it's overexposed. Right?
Yeah. So I'm going to have to, I guess I'll stay in the Hangout and then hopefully, I don't know if I can.
I mean, you can always rejoin, right?
Tips on this one here. Let's figure this one out.
Because you had it before.
I did, but I had to change the settings for Jupiter. So let's see if I can change cameras in Google Hangouts.
You could change it to yourself or change it to your laptop's camera and then back to
Yeah. Exactly.
You can definitely change your cameras in the Hangout. And so, if people are wondering, we're looking at the moon right now. But the problem with the moon, and I think you're all going to get very experienced with this. The problem with the moon is that the amount of light coming off the moon is, vast multiples more than the amount of light that comes off of Jupiter. And Jupiter is way more light that comes off of other things. Oh, here we go. And so the moon is just super, super bright and completely washes out the CCD of the webcam until you change the exposure settings. And so for every object that we look at, you've got to change the exposure settings and then sort of fine-tune it.
So it actually did let me change it. I used a MetaGuide. I don't know if anybody's familiar with that program. And it complained that it was being controlled by another piece of software, but it let me go into the video settings anyway.
Mm-hmm.
Why it's kind of reddish purple, I'm not really sure. Probably. Oh, you know what? I don't have a good. I don't have an IR UV block in this anymore. That's probably why it looks a little off.
Did you have that before?
No, in fact, I defaulted the settings, and I think it upped the saturation. And when we were looking at the moon, the saturation was so low, and you're so used to seeing kind of a white, grayish color to the moon anyways, I don't think it mattered. So let's go find something interesting here.
Yeah. We'll find some craters, and it looks like the focus is a little off too.
Yes, and the seeing isn't super great. This is again through the 2.5x PowerMate, so I can pull that out if you want.
Yeah, we should probably do that. Well, I don't know, it's sort of a mixture, right? Like, can you try and sort of tighten in the focus, and then maybe we can see just some of the craters at this high resolution, and then we can try a lower a lower magnification.
Ooh.
But even some of the craters are over on the limb, right?
Is that Rupes recta? Is that the straight wall there? Kind of in the lower right?
Yeah, I'm not sure.
Who's a moon person? I'm not a moon guy.
I'm not a moon person either. Phil was talking about that before. Last night we were doing this with Sabine, and he had his moon map going, and we were sort of trying to cross-reference, like, what are we looking at? Oh, that's the Sea of Tranquility. Right. So.
It's collaborative navigation, right? No. You got to make a left on the 101.
Can you move off to the right a bit, or?
Yeah.
See if we can get, because the shadows are a little nicer over on the side. Sorry. What was it? Jay Green said, 5 telescopes. Oh my God. Yeah, no problem. If Sabine was paying attention, he would be able to connect in his footage, and then we could just click between the two of them, right? And Jay Green wonders about the moon is so bright, will it heat up your eyes from the eyepiece? No, you don't heat up your eyes looking at the moon.
No, but it gives you what I call moon eye.
Moon eye, where you've got one eye.
Because usually you look through an eyepiece with one eye, and then the other one you cover or you just hold it, and so you have this weird. It's the same thing you do when you open the fridge at night, right? You can't really see, and then kind of blink one eye, and then the other one stays open, and you can't see straight after that. It's this weird stereoscopic thing.
But it's weird because you've blown your night vision in one eye, but not the other one.
Exactly.
So it's a very odd experience. Yeah, I know what you mean. You feel half blind walking around trying to use your telescope. Corey Wilder wants to know: is this a CAS? So like a Schmidt CAS ring? Yeah, it's a Celestron. It's an 8-inch Celestron. It's one of the short ones. Schmidt CAS ring. And is the image inverted? It depends on the point of view, right? I mean, if you're in Australia, or if you're in the northern... Whoa, there we go. There's some craters. You can see some of the darker parts and the lighter parts. There you go. There's a beautiful crater up at the top there. I mean, I don't think people can realize. I mean, the amount of the field of view here is really tight. So we're not actually seeing very much of the moon at any one time. It's also a little dim. Can you try cranking up the brightness?
Yeah, I can. Let's see here. Let's do...
Yeah, there we go.
It's nice to be able to do that on the fly.
Yeah. These are all just experiments. Like I said, my goal is that we get five telescopes and pointing at different objects, different scales. We get a couple of astronomers explaining everything, and we just do a star party. So this is the beginning of this. And so Sabine was able to get his feet in, and if anybody knows anybody, any other astronomers, I mean, part of the problem with all this is it depends on everybody's seeing, and it depends on everybody's, it depends on the weather, it depends on whether you're rain or clouds or whatever. So, and even what parts of the world you're in and what you can see. There's constellations and objects that Mike on the east coast of the U.S. can never see, right? You'll never be able to see the Southern Cross or the large Magellanic Cloud and the small Magellanic Cloud. Those are all only visible to folks in the Southern Hemisphere. So we can get some people from the Northern Hemisphere and some people from the Southern Hemisphere all operating at the same time. That would be great. Wow, look at this.
There's a couple good ones here.
Yeah, those are good. And you can see right at the very heart of these craters, there's like a point in the middle there. And so what you've got is it's almost like an asteroid crashing into the moon and then the rock splashing up in the middle, and then you've got this point in the middle.
I'm going to try to play with the focus again here. Let's see.
Whoa.
Wow. Okay, everybody hold your breath. Don't move.
Yeah.
It's one of those nights where you just can't nail the focus.
Eric, you wanted to know what aperture does the telescope have? So it's an 8-inch telescope, and it's a reflector, but it's one of the stubby ones. So if you've ever seen the kind of classic Celestron 8-inch telescope, that's what Mike is using.
Yes, the orange one.
The orange one, yeah, the classic orange telescope. This is, it's like a classic, workhorse telescope. The telescopes like this were in the astronomy magazines that I was looking through when I was 13 years old. Wow, look at that.
That's a good. Let's hang on this one for a little bit here, because
yeah, for a while there.
These ones along the edges here, you can actually see as though you were, it's at such a sharp angle. It's almost like flying over the moon.
Well, we were talking about that last night, that how a lot of people think that the best time to look at the moon is when the moon is really full, but it's actually not, right? The best time to look at the moon is when you've got a quarter moon or even a sliver of the moon, because then the sun is coming in from the side, and you got these big, long shadows that really show in relief what the moon looks like.
Yeah. You know what I also like is at a high magnification here, you can see the walls of the craters too.
Yeah. We should be moon guys. This is beautiful.
Yes. So who can tell us why the bottom of most of these craters here are flat? I don't have the answer. I'm actually asking because I really don't know. Is it lava flows? I'm filled in by erosion, maybe. There's a nice one up in the top left. Let's pull that one up a little more.
So Jay was noting that when you get your bigger telescope online, then we'll really be cracking. Yeah.
Oh yeah. Yeah.
Absolutely.
So there's another piece, for those that are interested in imaging or just observing here. In my part of the world, in North Carolina and the United States, we have large temperature swings between the night and the day. It's usually, it's quite common to have 20 or 30 degree Fahrenheit temperature changes. And anybody who's lived in a warm climate or during the summertime looked across the asphalt driveway or parking lot, you see the heat waves coming off in the summertime. That's basically what we're seeing here now. And there's not much you can do to fight the air temperature changes, but one thing that you can control slightly is the mirror temperature and how the mirror temperature retains the heat relative to the air temperature. And so one of the things I bought for this telescope was a Limax cooler, and all it does is has a little tiny fan, and it takes outside air and blows it through a long tube inside the baffle of the telescope, because it's a closed tube, and disperses that cold air inside the actual closed container of the telescope tube, and that in effect reduces the temperature of the mirror kind of by indirect air currents, right? Whatever the thermodynamic property is for that.
Right.
And that actually helps, especially when you leave the scope outside to cool for an hour or two before, and then even run the cooler for the 15 minutes or so that you're setting up, or even the whole hour, right? Because all you're doing is blowing ambient air temperature against it, and it actually does help a lot. And I actually, for my other telescope as a Newtonian, I built a Peltier cooler because the mirror is 15 pounds of Pyrex, and it takes a little bit longer to get to ambient. So there's actually details on my website if you're so inclined to look at it.
Right, but this is one of those situations that if you live in a place like you do,
yeah,
almost anyone can get a benefit from that if the quality they're seeing is really important to them. Where you can try and control some of these problems. As you can see, this atmospheric distortion is a rough one to get past. Also, when you're jiggling the telescope.
Yeah, I'm so touchy. I always grab the focus knob, and whenever I think it could stand some improvements.
Yeah.
I love this. There's the little floating pieces of rock just above the dark limb there, right?
Yeah.
Kind of towards the top in the center.
Oh, look at that.
It's like a little mountain peak just exposed by the light, and the rest of the base of the mountain is just covered in shadow still. It's like a little broken bite floating off into space.
Yeah. And it's kind of interesting. I mean, people don't, people talk about like the dark side of the moon, right? But I
love that album, by the way.
You know that album? Yeah, it's a great album, right? But there is no dark side of the moon, because the moon orbits the Earth, and so at various points in its orbit, the entire moon is lit, but the moon has a near side and a far side because the moon is tidally locked to the Earth, and so we only see one face of the moon, although the Earth is rotating. So if you're on the moon and you were looking at the Earth, you would see the Earth rotating in front of you. But from our perspective, we always only see one face of the moon because we've kind of wrenched the moon into position, so then that's all we see. And so this is sort of one of those examples where you can see some features that they just remain. I mean, in this case, it's all purely how much of the moon is in sunlight from our perspective. I mean, half of the moon is always in light from our perspective. But if if you focused on this spot on the moon and we watched it for hours, we would see that change. That, in fact, maybe it's already changed a little bit, hasn't it? I don't know if you can still see that little part sticking up anymore.
Let's go back. Yeah.
Or maybe it's more lit, right?
Magnification on the scope's not that good. We'll have to watch it for a few hours.
Yeah, for a few hours. But the point being that
you
would see these kinds of changes. I'm not sure whether that side of the moon is going to brighten up or darken. But can we go to the other side of the moon?
You want to go to the lit side? Yeah.
The lit side, yeah. But even just
I can get control of my telescope again.
Yeah. Again, if anyone has any questions about what it is that we're seeing or what we're doing, feel free. If you link to an 8-inch, Eric, you just link to a telescope. It's an 8-inch Celestron Schmidt Cassegrain. I mean, it's the most regular telescope.
Yeah, it's a pretty flexible workhorse. I mean, you can do deep sky with it, you can do planetary with it, you can do imaging with it. It's actually the one I have is the single arm fork. I think they still sell it. And I think the net weight of it was 27 pounds. So, I mean, you can really just pick it up and move it wherever you want.
Yeah. And so you can see from this side, it's going to be as beaten up as the other side of the moon that we're seeing, but because the light is hitting it directly, we're just not seeing those long shadows, and also your focus. But yeah, you can see you're tightening that up.
Yeah. A bit more. Yeah, let's put the hand controller down. Usually, just even the cord moving at this focal length is enough to make it jump and jitter.
Yeah, it's such high magnification. I don't know. Do you think it'd be worth pulling it out and getting? Because I find sometimes like a medium magnification with the moon looks pretty nice too.
Yeah, this is the 2.5x power mate, which is about f25. So I'll pull it out and it'll go down to an f10, and it'll look a lot sharper there. So
yeah,
go ahead and do that.
All right. So just because with a telescope, you can't zoom it the way you can zoom with a binocular or like a right? So the way you change, and the thing is that you can never change the amount of light that's actually coming into the front of the telescope. The telescope is the light that's coming in. And so what you can do is you can swap out your eyepieces. And so you pull one eyepiece out, then you put a different eyepiece in, and then there's another gadget that you can put in. I mean, it's like a Barlow lens, right?
Yeah, it's exactly what it is.
Yeah. And so you can put this piece in front of your eyepiece called the Barlow lens, and then that is a multiplier. It multiplies the magnification of what it is that you're seeing, but it also kind of gives you less light. So and kind of concentrates it. And so you see a much smaller area, and it's a lot more jiggly, right? But you're not getting any more light, and this is the trick, right? So like if you magnified the view 1,000,000 times with this telescope, you wouldn't see anything, because it's all about how much light the whole telescope is drawing in at the same time. And in this case, I don't know, can you pull the exposure down one notch? It seems a little bright, but maybe we're on the bright
This is
side.
actually 1/1000th, and the brightness is. Bring the brightness down a little, maybe there. Or the contrast. Let's see.
Yeah, it's still.
Ooh,
Oh, here we go.
that's interesting.
Yeah, well, that's really nice.
Oh, you know what? Here, I can grab the gain and bring the gain down. There we go.
That was a little far.
Yeah.
There, right there.
Yep.
Now, is it not tracking anymore, or are you?
You know what? I never I never changed it to lunar tracking. It was set for sidereal still. So
Right. So just to be clear,
lunar. There we go. That'll help a little. My tracking is probably pretty severely out still, anyways. Even though I tried a little harder.
Yeah, it's just not even set up, right? This is funny. Are people ordering telescopes? Josh, did you just buy a telescope?
I am not a paid Celestron employee.
Yeah, no, neither am I. Celestron is not sponsoring this, although they obviously should.
Yes.
I know this is going to, again, you are all our guinea pigs. This is us experimenting with what we can do.
I'm going to default these camera settings here because I think I got it too far out in one direction or another here.
Later on will be a oh, there, right there.
Oh, yeah.
That's it. And then can you tighten up the focus a little bit?
That's an interesting crater there. Let's see.
Yeah. Sure wish we knew what it was. We know. A big crater like that's going to have a name. Oh, that's really nice.
That's cool.
Yeah.
I do not spend enough time on the moon. I need to.
That's it. You're going to be a man obsessed.
Yeah. Now, so just above that large crater there, you can see there's another little piece of another crater kind of floating off in a dark area there.
Mm-hmm.
There's no... There's reindeer. I can turn reindeer on. But, yeah.
It's not...
No, that doesn't help, does it?
No, I don't think it's fine.
They need a little annotation. If you can submit feedback for just even a hovering mouse, I talk with my hands.
Yeah.
And, when you're doing this kind of stuff, you need something to substitute for that.
Yeah, we talked to them about that it would be really cool if there's some way that we could actually interact with, the host or somebody can interact with another video screen so that we could draw or point at things or things like that.
Mm-hmm.
Anyone else has a question? Well, I don't know. Do people want to just keep looking at the moon? I mean, are you feeling ambitious? Is there anything else that's up for you there right now?
Stars. It's pretty hazy, and I don't...
Pleiades up?
I can't even see it.
I mean, how does,
It was.
the globular cluster in Hercules look from... I mean, it's down right now, but how does that look through this telescope?
Oh,
all right.
It's fairly decent. I used the digital SLR camera I have for that. I can't even see the Pleiades right now, and it looks pretty decent in digital SLR on this camera.
Yeah. What about Orion, the Orion Nebula right now? Is that up for you?
It is. I can try it. Let's see.
We can always come back to this. I mean, although I don't know. Oh, that looks really good. I think you got this is the perfect, whatever numbers you have, make sure you write these down, because
yeah, probably should.
Look really good. It's a little washed out on the left-hand side.
Yes.
Where it's brighter, but where we're seeing a little less brightness, it just looks beautiful.
Go back. I think we're headed north. It's just inverted for me being in the northern hemisphere. That's an interesting crater there. You can see it's got a ray pattern around it.
Neil, we were looking at Jupiter before. Venus is down right now, and if you want to join, you got to hook up your telescope to the internet, and then we'll invite you into the Hangout. But this one, we're just trying to connect telescopes in, so it's not sort of the standard chat. That was earlier today. We're going to record Astronomy Cast on Monday, so yeah, we're all over Google+. Professor Zirl. Cool. Thanks. I thought this would give people ideas. I mean, all of the hangouts that have been happening so far have really been, you know, a lot of people with their headsets on their head talking to each other. And I think this is sort of the next level. We can do anything with these video screens. So, yeah, I
I
don't
like
know.
the southern hemisphere. Let's go back down there.
That looks really good too.
Yeah, this is the lesson in this is don't always put the biggest eyepiece in that it'll take. Right?
Yeah, that's exactly right. Is that when you know what? Now that you got the exposure settings under control, I bet you if we go back to Jupiter, we'll probably see the bands a little nicer with a little less magnification.
Yeah, we give it a shot. Oh, let's change it to sidereal from lunar.
Right?
And
I was looking at Monday. I think we're recording at noon on Monday, but that's our astronomy. We're recording our episode of Astronomy Cast. But if you have never heard Astronomy Cast, we're up to episode 247. I think we're going to be recording. I don't even know what the topic is, but so if you do a search for Astronomy Cast, especially on iTunes, we've got hundreds and hundreds of episodes. So if anyone's at all interested in this, here's the part where I go into marketing mode. We've got all of the space reporting for Universe Today. We've got Astronomy Cast, which is this weekly podcast that we do about space and astronomy. There's Phil Plate's Data Astronomy over at Discover Magazine. And we did a big hangout today as well with sort of people from all the space journals, and we want to talk about the current events in space news. So this is something different.
yell if you see it, okay?
Oh, okay. Sorry, I wasn't looking. Hold on.
That's all right.
If you're watching comments, but yeah, okay.
I need my little flip mirror here.
But you're on. I mean, you've got the right magnification now. You've already popped the Barlow up, so you know we should be able to see it when it zips into the view. And then in terms of planets, so if you go out at night, or I guess if you're in Hawaii right now, Venus is the bright star that's visible over on the western horizon. It goes down about 2 hours, 3 hours after the sun goes down. Jupiter is that really bright star that's really high up in the sky, and it's pretty much there all night. So if you go outside and you see a really bright star, you can do it right now. You're most likely going to see it. You still there, Mike? I think I might have lost Mike. Nicholas, we're gonna record Astronomy Cast at noon on Monday. So I can't hear you, Mike, if you're trying to talk. You can watch, Nicholas, and then at the end of every episode, sort of we record the episode itself, and then we open up it to the Hangout for people to join us and chat with us. So if you have some astronomy questions, then you can join us at the end, and we'll try and answer them. Thanks, Jay. How'd you like it? David says it would be really interesting to have several people with webcams on different scopes in a Hangout. I totally agree. This is the plan. And so what we're doing right now is we're just running experiments. Every time a different astronomer gets their telescope running in the Google Hangout, I connect with them and get them to try and sort of we can do a live broadcast Hangout. But yeah, absolutely. The goal is 5 telescopes, different astronomers at different parts of the world, all pointing at different things, and then we can just click to different views depending on what people are seeing. So we're back to the moon, I guess. But I've lost your audio, Mike.
Yes, I got a very important phone call from my wife in the house.
Okay.
So I figured I'd mute out. You didn't have to listen to me jabber away.
Yeah.
I also couldn't find Jupiter, so we went
Oh.
back to the moon, and I'll move around here a little bit. This is my second-rate setup, so it's not as easy to find things.
Yeah.
Well, I will get the other scope running next clear opportunity I get, and probably be able to see a lot more.
Yeah. And then the other thing is if I think Mars and Saturn are up in the morning.
Yes.
So, or late, I guess late in the night. But
Yeah. So if I did that, I would probably be up at like 4 or 5 o'clock my time, and I know you're 3 hours behind me. So would you facilitate something at like 1 or 2 in the morning if I gave you a heads up?
if you gave me a heads up, I guess maybe I'll just make an Australian do it.
Yeah.
And then it's, but like I said, different times of the night. I mean, for sure, I'm up for anything.
Okay.
Yeah. I mean,
Because Saturn is definitely one of those things that, for people that aren't into astronomy and haven't seen things through a telescope, that's like, that's the definitive quintessential, like, holy cow.
yeah, that is the moment. That's exactly right. If you have never looked through a telescope and you hold up your eye to an eyepiece and you see Saturn, it blows your mind, and you cannot believe that you're actually seeing Saturn. And you see the rings and you see the ball, and it's the real deal. Yeah, absolutely. Yeah, Saturn is great. Mars is not that exciting. Mars is a little red ball. Venus is not very exciting at all. Kind of depends on the phase of Venus, which I know sounds really weird, but you can see Venus looking like a really bright crescent, or you can see a very small ball, but you don't actually see the surface features in the way that you do with the moon, and with Saturn you see the rings, and with Jupiter you see those bands and the moons. So
I think this is around that spot we were looking at under the higher magnification, and there's that mountain again.
yeah.
Change the rate.
Nicholas said, need a scope, any ideas? So just in general, when people say that they want to buy a telescope, I mean, that's great, and we love that people want to buy telescopes, but when you buy a telescope, you're often disappointed at what it is that you're seeing, and how what it's like to get into this hobby in the first place. And so what we really recommend that people do, instead of buying a telescope, is start with binoculars. Like a really nice set of binoculars that's going to be great for astronomy isn't going to set you back more than $50. You could even go and use like some, your standard binoculars, 8 by 35 binoculars. And those alone will give you a much better view of the night sky. You can see some of the really nice open clusters of stars. You can see some stuff on the moon. The moon looks quite nice in binoculars. And you start to learn your constellations, and you start to kind of get to know the night sky. And if you still find yourself really entertained by that, then you can definitely move towards getting a telescope. But I mean, a lot of the really amazing pictures and a lot of the really amazing work comes from astrophotography, and that's when you've hooked up a camera to your telescope and you're gathering, like we said, you're opening up your aperture and you're getting 30 seconds worth of view. And so, people want to get involved in astronomy. We recommend always is like get yourself a planisphere, get yourself a great book. My favorite book is a book called Night Watch. Go outside and just learn some constellations. You want to be able to go outside and look up and go, oh, there's Orion, and there's Cassiopeia, and there's the Big Dipper, and there's Little Dipper, and just get to know your constellations. And then, take out a pair of binoculars and then start, you notice fuzzy bits in the sky, and there are a bunch. There's Pleiades, and there's Andromeda, and some of the clusters, and take your binoculars and take a look at them and sort of, just get to know the night sky. And if you're still entertained by this, then think about buying a telescope. For about $250 about $250 to $400, you can buy a nice Dobsonian telescope. You can buy like a 6-inch Dobsonian, which doesn't have the fancy tracking that Mike has got going on here. It's more got, but it's a nice big telescope, and so you're going to get really good views. I mean, you're going to see the moon almost as nice as what we're seeing right now, or you're going to see Jupiter, or you're going to see Mars, and especially if you've got better seeing, the views you'll see will be as good. And the Dobsonians are very cheap because they're very simple. They are a great big telescope that's on a mount that's on the ground, and so you learn to sort of move the telescope around and aim at various objects in the sky and learn where the sky is. A lot of the purists really feel that that's a good way to go. And again, if you find yourself if you're going out every night and you're showing people the sky, then you can kind of move to a nicer telescope, the kind that Mike has. I mean, the trick with what Mike's telescope is that it's got a mount that's a sort of a fancier mount. It's got a like an equatorial mount on it that's motorized, and so what he can do is he can line up that mount with the axis of the tilt of the Earth's rotation, and then aim at stuff in the sky, and then track it as it moves, because it's not moving, the Earth is rotating, but we get these. These objects, when you look at them with a Dobsonian, for example, you'll see them, especially if it's high resolution, like high magnification, you see them just kind of drift right through your field of view really quickly, and so you're constantly having to kind of align it. And the problem is that you're moving it down, you're moving it over, you're moving it down, and you're moving it over to try and keep things in your eyepiece. But if you have like what Mike has, he's got a very nice mount, then it's tilted off to the side, and then you just have one little knob that you turn, and that keeps the whole telescope aligned. And then even fancier than that is like a go-to, but it's a motorized tracking. And so you get it lined up, and then you turn on the tracking, and then the telescope just stays perfectly aligned with that object and never moves in your field of view. And then sort of the next thing above that is you have what's called a go-to telescope. So you say, telescope, show me Jupiter, and then the telescope moves over and shows you Jupiter, and then you say, telescope, show me, Pleiades, and the telescope moves over to Pleiades. So each one of these advances are good. The problem with those really expensive mounts, or the really complicated mounts, I mean, they do have them on cheaper telescopes too. I mean, you can buy a $400, $500 telescope with a go-to system, but they're kind of finicky to set up, and so it's really hard from a hobbyist point of view that you're going to go outside and you're going to set up this complicated telescope just to see Jupiter. And, by that time, if you're going to do this at a party and you're trying to get it all aligned, you've bored everybody because you're like, no, just a second. I got to get the GPS figured out. And it's just not as fun. I mean, if you're going to be out there for 4 or 5 hours, you're going to do a lot of observing, then you're definitely going to want a nice automated telescope. But if you're just going to go out and check out the planets and show people, then I really recommend like a 6-inch Dobsonian. And they're very inexpensive. Orion has a really good one. Almost all the manufacturers have them. Whew. What's happening over on the telescope?
There's a mouthful. You want to take a little drink of water there.
Yeah, no, I give this speech almost every night.
I think you're right, though. I think it depends on what you want to get out of it, too, right?
Yeah.
I mean,
yeah.
if you're discovering the universe, you don't want the equipment to get in the way, and depending upon your level of expertise and your level of patience.
Yeah.
And you gotta think about what you want, right? And like I said before too, the one thing that I wanted was a powerful telescope, and an 8-inch is a powerful telescope, but I also wanted it to be portable. I actually do have a fair amount of trees which inhibit what I can look at any given time. I can't I don't have full sky access. I have to kind of pick and choose where I want to set mine up. So I have to move it around a lot. So I wanted something that was light.
Yeah.
And so I kind of went with that approach that I want something as big as I can get and still move it around.
Yeah.
You know, and I'm comfortable with my own ability to do those things and pick the thing up and find the objects I'm looking for, or not having it on a permanent mount or in a permanent home.
Corey in the chat, Corey Wilder said, I bought a 12-inch Dobsonian, and it's great, but it's so cumbersome that it doesn't use it enough. And I think that's the point, right? A 12-inch Dobsonian, you know, it's a foot across. The tube is, you know, 6 feet plus. The thing's going to weigh a lot, and trying to get it, as you say, to move it around, it'd be like, oh, you know, Jupiter's gone down behind that tree, but if I just move the telescope over, you know, then I'll get in there. You know, and so that gets really complicated as well. So Dan Delasio says that a 10 by 50 is a good place to start, and I totally agree with him. You know, that's a great entry-level set of binoculars. You know, the two numbers in the binoculars, right? 10 is the magnification power of the binoculars. 50 is the size in millimeter of the sort of the gathering power of the two telescopes, the two halves of the binocular, right? So if you get, say, 100, then it's going to be 100 millimeters on the binoculars. And if you get, say, so when you buy like an 8 by 35 set of binoculars, it's 8 magnification with 35 millimeter lenses on it. But so a 10 by 50, it's 10 magnification with 50 millimeter lenses, and that's really nice. I mean, then you're getting some nice light gathering power, good magnification, really nice. They get bigger. I mean, you can buy like 100, like 25 by 100s, right? So it's 25 magnification, 100 millimeter lenses, and they're really big. And then it starts to get to the point that you can't even hold these monster binoculars up to look at the sky. But that's a whole other kind of hobby. I mean, there's a lot of people that feel like that the only way to go is to use binoculars to view the sky. So.
Yeah, I think the other aspect is there's visual observing, right, and then there's astrophotography. And as I talk, I lose the moon. And you know, you may start out like I did down one path, saying, oh, I'm going to buy this and I'm just going to look through it, right? I'll get some nice eyepieces, and you get a little eyepiece accessory kit, and you know, it becomes engrossing because then you're like, well, hey, how come I don't see the same things that I would maybe on the computer or on the internet, right?
We don't have anything on the screen, by the way.
What? My deck motor slipped again, so I'm working my way back in. There we go. So yeah, I got sucked into astrophotography because I couldn't see the things that I wanted or that I thought I should be able to see in a comparable telescope, right? So when you look at other images that people took through their 8-inch telescope, mine didn't look like that when I looked at it through an eyepiece, no matter which eyepiece I looked at it through. So I got into astrophotography through that means. And I will say, having kind of a discerning eye here, having a, I guess, experience looking through this telescope with different eyepieces and comparing it to what I know I can do with a good quality camera if I took a photo, and then relating those experiences compared to what you see here, I think you're kind of somewhere in between. I think the Google Hangout and also the compression maybe through this particular camera doesn't lend itself towards what you might even see through an eyepiece. I think with an eyepiece you might see better views than you would actually through here. So, you know, there's different experiences, I guess, even within the same class and capabilities of the telescope too.
Yeah. So if people have noticed, Pamela Gay has joined us to
Hello.
Our party here. So take a look, Pamela. What do you think?
I think that looks absolutely amazing.
Yeah. We've got the Barlow out right now, but we had Jupiter, and it looked great too.
It's getting on the low side now. If I could even find it again, I could try if you like.
But why don't you go back up to the top, and then you can just raise it well.
I'm just amazed at how easily you can tell the differences in terrain and see the fault lines and everything else. the light material around the craters is actually material that was splattered during the crater process.
See, you're the one that we should be asking all those questions. Now, did we remember what we were asking?
Well, you said that that's that's the Dragon crater, and that's the.
Yeah, no, you need Phil if you want to know the names of the craters. To me, they're just all craters. It's the same physics.
That's the Mississippi, and yeah.
Yeah, I think the Mississippi is actually about 2 miles that way.
Oh, is it? Okay, all right. No, we were just noting that we didn't know anything about the moon. Right. Someone wanted to know. Adam Alexander wanted to know what an equatorial mount is.
Okay.
And an equatorial mount is just one of these mounts where the telescope is tilted to match the tilt of the Earth, and so you get so that then you don't have to do this down over when you're trying to watch things. So
the nice thing about equatorial mounts is, since the telescope has to move across the sky at the same rate that the Earth is turning, you can literally use a clock drive to run one. So these were the very first drive systems built. You lined the pole of the telescope very carefully up with the north rotational pole of the planet, set the clock going, and the telescope just tracks.
So Matt Arnold had a bunch of suggestions for Google on Air. Higher quality video. The weird thing is that we see higher quality video than you do.
Yeah.
So, we've got actually really high resolution video in our Hangout window and really good audio, but you don't. And I think it would be nice if that was broadcast and also if the audio was stored, because I've found that the audio that people see, or the audio that we've seen that's been rendered after the fact is pretty bad.
Yeah.
It's too bad. Although I'm not using any of my equipment right now, just using my MacBook. Submit a question. Well, yeah, Matt, if you have questions, you can ask them in the chat. I mean, this is, create shows and have subscribers. That's a good idea. Yeah.
Yeah, that's actually on our to-do list.
Well, no, but to have it somehow built into Google Plus so people can...
Oh, yeah, that would be fabulous. It's one of the things I was talking about the other day, is desperately wanting something that was a online version of meetup.com. So imagine being able to do all of this in a virtual meetup.
And part of the problem that we've had is that people have no idea that we're doing this.
Yeah.
Right? And so we get people are just finding out just randomly that, hey, what? They've got a telescope hooked up to Google Plus? That's pretty weird. And so it would be nice if we could actually let people know and notify them.
Yeah, I think the challenge there is weather more than anything else.
Yeah.
Even if you had a large number of participants, right? Now, I tend to know when the really good seeing is coming at least a few days in advance. And so if I know I'm going out, I'll definitely throw the word out there to you guys. We can maybe even schedule times and things like that.
Yeah, exactly. And again, it might, we're finding astronomers who can do this. My dream is that we get 4 or 5 telescopes all going at the same time, and then we can just switch from scope to scope and explain what we're seeing, and people can do that. We've had one person actually go and just buy a telescope outright, Pamela.
Oh, wow, that's fabulous.
Yeah, 8-inch Celestron bought.
That's pretty awesome.
Yeah.
Yeah, I actually had an epiphany while eating dinner tonight, which is always bad because then I end up spending the entire rest of dinner thinking, I need to go home and code this. And then I have, of course, a long to-do list once I get home, so it doesn't happen immediately. Is one of the things that is now on my to-do list of things to do is write a page that if we don't have a hang-up going on, it says, no hang-up going on at the moment, stay tuned, and then it lists the times that we're planning to do events. Mm-hmm. And then it has a back-end admin site that the second we know we're going to do a hangout and we have the URL, we plop it in, and then it becomes an automatic redirect.
Yeah, and I think this is sort of part of what some people were getting at, is that if we had a channel, then if there's nothing on, then it would just be a blank screen. It would mention when things were going to come up next. But if we actually had some video happening, then people could go and check out what's going on. I mean, the reality is that we can queue up all kinds of stuff. I mean, we have lots of science content, lots of people who would love to participate, and I mean, you could just imagine some of the amazing things that we could get going on live. I mean, people dealing with bugs and, you know,
so I just want to point out the area that he's looking at here. Look at the amazing faulting right there in the lava. So there's this area where you can actually see the surface is cracked. The moon, we don't think of the moon as having volcanoes, but if you look at it closely enough, which means you use satellite data, it's covered in shield volcanoes, just like Iceland is. And it's these dark areas of lava that we end up finding all of these neat cracked features within. Sorry, Fraser, I just wanted to point out they're really cool. Well, yeah, I was going to say it looks like a skull's nose,
Yeah,
but...
exactly, yeah. Well, because it helps you kind of people to visualize where we're talking about, too, because I see what you're talking about. Coming out of the, I guess what would be my left, right?
Yeah, there's two eyeballs.
Yep.
Clearly it's rolling its eyes.
Yes, I think the seam is deteriorating, too. This is,
yeah.
It used to be a little bit sharper than this, with this focal length.
Oh, no, it's still pretty phenomenal. People noted that that the video in the small video looks really sharp, but the larger video looks a little more blurry. And the thing is that what's the resolution of the webcam, Mike?
Yeah, it's a 640 by 480 now. On my desktop, it's actually bigger than that. So I think Google is doing some transcoding or something too.
Yeah, and so, you know, on my screen, it's bigger than 640 by 480, so it's actually blowing it up a little bit. But then on the small window, it's shrinking it down, and so you're getting a much tighter resolution. But it's just, if you take a certain amount of information and you blow it up bigger, you just get more noise again. So can we try for something interesting before we sort of wrap this up? Do you want to try something ambitious?
Orion's out right now, and it's high in the sky.
Yeah, we were talking about that. I mean, can you take another crack at Jupiter?
I can, yes.
Or the Pleiades is bright.
I actually can't even see it. It's so hazy here tonight.
Oh, really? Where are you?
North Carolina.
Okay.
It said clear tonight, but I just see little spotty clouds all over the place here. Where is it relative to the moon? Oh, it's really close. I do see it. It's
Pleiades is right beside the moon?
Yeah, it's probably only about 4 or 5 degrees away. I'm sure it would show up okay on the camera. I just don't know if I can find it.
Yeah, well, and it's an awful big object, about the size of the moon.
Yes. Let's try. Give me a minute here. We can try the Orion Nebula.
Okay.
You want to try that?
Yeah, the trapezium at least will show up.
Yeah. Let me give it. I'm just going to pull the camera out here for a second, and then we'll try.
We did have a good, but really good seeing at Jupiter earlier, which was great. And we could see some of the moons.
Cool.
I can go back to Jupiter, and then we can. Jupiter's shrinking. I can try that.
Not just the two bright bands, but you can bands above and below the top and bottom of the planet earlier on. And it's mostly just been Jupiter and the moon right now.
Okay.
Yeah.
So one of the questions is, why are crater floors flat with the Q? I'm not sure what you mean by with the Q, but I can tell you why they're flat.
Well, we actually, this was Mike actually asked that question not knowing, and so we started making up answers. But yeah, so please tell us why.
I want to know your fake answer.
You would think that I would be a knowledgeable guy owning a telescope, but I really didn't know.
No, I'm actually just now learning so much about geology because of the citizen science projects that I work with. I managed to make it all the way through until my 30s without learning any geology other than the stuff you have to learn to pass 8th grade. So with craters, it's literally a matter of the object goes in, digs a hole, splashes material back up, but the material is basically liquid as it's splashing back in, and just like a lake forms a flat surface, the liquefied material coming back into the base of the crater forms a flat surface. Now sometimes you'll end up with a splush in the center, and I have to admit I don't remember the physics of why you sometimes get a central peak.
So is it really the heated material as it settles, or?
Well, it's not even the fact. I mean, it's heated, but just the whole process that it goes through basically liquefies it in how it acts physically. So just like you can have gas that acts like a liquid, you can have soils that aren't necessarily molten, but they still act like a liquid.
See it.
Is that Jupiter?
Yes. Now this is the low magnification, but let's start somewhere, right?
Yeah.
Modify the
Gain.
exposure. Yeah, he was able to control it on the moon, so I think he's moons.
Ooh. Pretty.
That's more than we saw before, isn't it?
I know.
Well, they move.
Yeah, but not that fast.
Yes, they do. Well, you've been doing this for a couple of hours, haven't you?
Yeah, I don't know how long it's been. I'm getting cold in my toes, I know that.
Oh, don't ever touch cold eyeball to cold eyepiece if you like your eyeball.
Well, that's weird. We lose our moons when you.
Yeah. This is a really second-rate camera. But we can.
Oh no! Don't make us choose.
You can have color and really ugly views, or you can have black and white and very
Can
beautiful.
you do the really ugly view and change the scaling on the display to logarithmic?
Who?
Okay, so when you display images on a good camera controller, you have the choice of displaying them with a linear scale or a logarithmic scale. And if you do a logarithmic scale, it allows you to see both bright and faint objects at once.
I don't have that setting on this camera. However, there's something called low light gain. Turn that on. Let's see if that helps a little. You can see it kind of flip it in and out. And then there is, let's see here.
So, just to sort of clarify for people, when you look at Jupiter, you can see the Galilean moons, and that's the 4 moons that Galileo discovered: Io, Europa, Ganymede, and Callisto. And so we're seeing 2 moons off to the right there, and then a 3rd moon further off to the right, and then I think we saw a bright moon up to the left.
Let's go.
Yeah.
So if you really, we're feeling ambitious, could you,
Oh, God.
Oh, it escaped.
Yes. Well, I have a bad deck control, so anytime I move up and down, I run the risk of it going, and it slips out real far and real fast.
Yeah. One of the common, you have an equatorial mount?
It's a single arm fork, so it's kind of on the weak side for.
Yeah. So one of the common problems with equatorial mounts and mounts like he has in particular is they're designed to very carefully move in the rotation direction, the direction going from east to west. But they're not at all designed to go carefully in the north-south direction. And so the second you breathe north, they're kashunk, far, far away from where you want to be.
Exactly.
There's also often backlash in the system.
Yes.
If you've ever dealt with gears, backlash is death.
Oh, there's a moon.
Now this is F10, and you can see it's brighter than the others. I don't know if you can make it out as a disk. It's pretty low here on the East Coast now. It's probably below 40 degrees altitude now.
So which is that? That's Ganymede?
I'm pretty sure it is. I mean, it looks to me brighter than the other ones. Let's see if we can go back to the other ones too. They won't all fit at the same.
So Io's period isn't quite 2 days. It's 1.769 days, which means that over the course of one night, it will go most of the way from one extreme side of Jupiter to the other extreme side of Jupiter for winter nights like we have in the north right now.
I just think we weren't seeing them because we didn't have the exposure settings right. I mean, if he changes it to one thing, you can see some of the faint objects, and look how far away it is compared to Jupiter, right? There's no way they're all going to fit.
Actually, I take that back. It'll go from all the way out to in, or from in all the way out. It doesn't make it all the way across. It makes it the radius, not the diameter.
All right, so now, Pamela, now it's your time. What are we looking at?
I have to pull up a star chart.
Jupiter.
I don't memorize. I don't memorize the ephemerae for moons. I'm sorry.
No, don't worry about the moon. Just Jupiter.
Oh.
That was I'm throwing a soft.
Okay, so no, what we're looking at is the bands in the atmosphere of Jupiter, and the different colors are actually caused by slight differences in composition. What's amazing is the bands aren't all rotating in the same direction when you watch them in a video, they are actually all going in the same direction, but they're going at different rates. So this means that some bands will appear to pass others, and you get these neat convective cells in them that generate amazing storms throughout all of the bands.
But I mean, this view of Jupiter is better than I think I've ever seen in any of my telescopes.
Really?
Well, I've only had 4 and 6-inch telescopes.
Don't sound too surprised, Pamela.
Well, so I'm used to 8-inch, like the old orange Celestron. We had a ton of them at Texas, and we'd take them out, and Texas skies are just, it's dry and clear.
Yeah. Mike's running an 8-inch Celestron. That's what this is.
Yeah, you cannot break the old orange 8-inch Celestrons. They just go forever.
Should we pump the magnification up a little? It doesn't look too bad right now. We have some potential here. Let's go for it.
Kind of like, if you've got the focus set, I'd almost prefer to see if you can see Orion before you try to pump the magnification.
Yeah? All right.
Let's try that.
Okay.
Well, what about, I mean, and then do you think Pleiades, with this low magnification, Pleiades is right out of the...
I think you're just going to see little stars.
It's just going to be bright stars.
Yeah.
You really want... the best way to see the Pleiades through a telescope is through one of the televiews with like a 44-millimeter eyepiece in it. So if any of you are tech jocks, that's a good view right there.
Anthony wants to know, can we tell how many people are watching the stream? We cannot tell how many people are watching the stream. The only...
What was the answer to that? Do you know how many people are watching, or you don't?
Oh, sorry, my wife's trying to get in the front door.
Oh.
And my daughter thought that some person was trying to get in our front door. Right, so we have no way to know the number of people that are actually watching the stream, but we can do, if everyone plus ones that's watching it, then that gives us a rough idea of how many people are watching. So no, that would be nice to know, if Google wished to tell us.
Like, now imagine if they happen to couple this with Google Analytics, it would be gold.
Yeah.
I just like the fact that they are slowly adding features cropping across the top of the stream. I'm waiting to see what replaces reindeer.
Well, they had mustache, I think, for a while, didn't they?
I don't know.
Yeah.
I'm wondering if they'll have like leprechaun hats in the United States for St. Patty's Day and do regional things the way they do regional doodles.
That would be cool. That's probably too high. Let's bring this down. It's a very colorful background.
Yeah, you can tell you have some hot pixels.
Are you guys good?
Yeah, we're good.
All right, I'm going to shut down my mic and video. I'll be back in a sec.
Okay. So can you tell through your finder if you're looking in the right area?
I am. I actually pulled the camera out, and in doing so, I'm sure I messed up the focus position.
Okay. Focusing telescopes is a black art, and one of the problems is, over the course of a night, as the temperature changes, that causes all the metals to, depending on what they are, contract and expand in different ways. Well, if it's getting cold, they're contracting in different ways. And so you have your telescope literally taking itself very slowly out of alignment as the temperature drops through the course of the night. And this also has the effect of drawing your mirrors closer together and slowly taking you into new focuses. Then you add in the fact that you're slewing across the sky, and that changes the torques on the system. And so that changes the focus of the telescope slightly sometimes, depending on the system. And it really is a black art.
Pamela, I think you saw my other telescope, my Newtonian there. Mm-hmm. Yeah, that one has a motorized focuser that I control through the computer, so I can watch the live display before I capture it and adjust the focus in. It's a JMI focuser.
Yeah, those are nice.
Pretty pricey, but it was well worth it because it goes in like sub-micron increments of in and out travel. It's pretty sweet.
Excellent.
So we'll get that one up probably the next clear night when I have some time.
Cool. I'm going to check and see if anyone's saying anything in the chat. I just need to figure out where I hid that window. There's too many windows.
That is definitely the Orion Nebula right there.
Sorry, I'm going to get to your comments as soon as I, dig. It's an archaeological search of my desktop. And mine's not nearly as bad as my husband's. My husband has this amazing system where he has 3 20-plus inch screens that just kind of wrap around. You know, you get spoiled, though, when you're controlling the big professional telescopes, because most of them will have 3 of the big, whatever is the biggest of the day, screens. One that your telescope controls are on, one that you're reducing data on, and one that you're displaying the image that you're reducing on. And it's pretty amazing. But that's how you make it go.
I wonder.
Matt Arnold, can you PM me where the features list thing that I should add to is?
Aha!
Progress.
Yes. Ta-da! What am I? Oh, that's the trapezium right there on the bottom.
Yeah. That's awesome.
Exposure here a little bit.
So the donuts that we're looking at, the reason that out of focus objects look like donuts, and I'll never forget the first time I showed my mom Venus through the telescope. She couldn't believe how tiny Venus appeared, so she kept cranking on the focus until she maximized Venus. And then she's like, Venus's moon is completely centered in front of it. And I, being a teenager, didn't quite know how to respond to this, except to flee, so I fled. But the reason that you end up with this donut in the center is as you go out of focus, you're actually starting to see the secondary mirror on the telescope. So the way telescopes like this are set up is you have hole at the top, light comes down through the hole, hits the mirror, and then reflects back up, and there's a secondary mirror here. And this mirror has a hole in the center. So the light hits the secondary mirror, goes through the hole into the camera at the back of the telescope. Now, in general, you focus infinitely far away, so you don't see that secondary mirror. It's sort of like the trick when you're at the zoo and you focus beyond the fence with a large enough aperture and you no longer see the fence in your photo. You focus the telescope right and you no longer see the secondary mirror, but you go out of focus and you start to get that secondary mirror. Now the stars that he pulled up in this image, these are the trapezium and the Orion Nebula. So if you go out tonight, I think just about anywhere on the planet, and you look at the constellation Orion, he's diving into the horizon if you're in the southern hemisphere, he's standing on the horizon if you're in the northern hemisphere, and beneath his belt is a sword, and in the center of the sword is this fuzzy blob of light if you look with your eyes, and when you look at it with binoculars you start to see stars popping out. When you look at it with a telescope, these are the bright stars in the center. And these are actually the very first stars to be forming in a giant star-forming region, or at least the first stars to be forming in this cloud of a giant star-forming region. There's lots and lots and lots of other stars that have been forming. And in star formation areas, the first stars to form are the biggest, the hottest, the shortest lived. And these are some of the hottest stars in the sky. They're not in the top 10 hottest, but they're among the hottest class of stars in the sky. And they'll all die bitter deaths at a young age as they burn through all of their mass way too fast.
It's depressing, but I'm sure it's beautiful.
Well, it's how we get supernova.
Yes, exactly.
Or at least it's how we get one type of supernova.
So I don't think this camera is sensitive enough to see any of the nebula that surrounds this area here, but this is really in the heart of it.
Yeah, if you pump the gain, you'd probably blow out the stars and start to get the nebula, but I'm guessing you'd need a 5-second exposure, which makes it stop being video.
Yeah, and this only gives up to 1/5 of a second right here.
Okay, yeah, not going to see it.
Let's see, I can up the brightness, but I think it's just too noisy.
Yeah. So the problem with detectors like this is they're not cooled, and what's happening to create the image is you have a bunch of little pixel photodetectors, and when a photon hits them, it knocks loose electrons, and each pixel is designed to keep its electrons. But if it's warm, the electrons start jumping bins, and they start jumping bins even without light hitting it. And we fix that in professional astronomy by cooling things down with liquid nitrogen. But with a...
Handy, Mike?
Yeah, I don't have any. If you want to ship some to me, I'll try it.
Yeah. Well, and I'm guessing you don't have any cooler on your camera. Some amateur high-end cameras, in fact, most amateur cameras now, have forms of photoelectric cooling. They get things down to -40 or so. But with an everyday webcam, the best you can do is to go out when it is -40 outside, which kind of sucks. Or if you're truly desperate, you can freeze your camera before you go outside.
Somebody warm me up. You're making me colder than it is here. It's only 40.
Mira asked, although Yako answered, Mike is using an 8-inch telescope. It's visible light, so this is just what your eyeballs see. And no, we're not using adaptive optics. Adaptive optics are only sort of equipped on gigantic, observatories.
Some amateur telescopes, the really expensive sensors, have what's called active optics, and those can tilt and tip to respond to the atmosphere, but it ups the price.
So do you want to go back to the moon?
Yeah, we can. And the other, I guess for those that are curious of the hardcore, the camera that I'm using, when I remove the little plastic lens that's meant to focus on your face, because it's a webcam, has a built-in IR block. And when I remove that, I didn't put one. I do actually have one, but I didn't put an IR block filter in place. So I think it does tend to skew the color balance. I don't know if that's why it's kind of slanted green or not,
But not putting it back makes you more sensitive, so that was the right decision to make.
That's true too, yes. Although I think it makes Jupiter look a little stranger than it might, at least from a white balance standpoint, right? So yeah, so we can hang back out over the moon. Are we leaving the trapezium here?
Sure.
Yeah, and then maybe you can try doing a little bit of observing with the 14 tomorrow.
If the clouds hold, I will take it out, because it is the weekend.
Or whenever, right? I mean,
take it for a drive.
That you can take it for a drive and kind of try and figure out what you can see, and if Andromeda got or Jupiter, Moon. I mean, what's going to look really nice as well are some clusters. If you can find some globular clusters with the 14-inch, that'll probably...
Or double stars.
There was... one of the planetary oppositions, I think it was Saturn. Saturn was near was in Virgo last year. There's a really Porrima? Gamma Virginis, I think it is. That's a really interesting double. It was actually moving apart over the last 3 or 4 years, but it was resolvable with the 14-inch. I can't remember which telescope I had. I've only had the 14-inch for the last year. Boy, my memory's just shot. That was actually a cool double, yeah. So, let's see, where did my moon go here?
There's frightening research that shows that sleep deprivation causes memory loss.
No! Look at that star. There it is. All right, other direction. There it is.
Good Lord.
Ooh, hot tamales.
Oh, moon. For some reason, I thought we were going back to Jupiter.
Oh, yeah.
It's late, and I have no memory.
Okay, I upped the magnification to 1,000,000.
Craters within
Am I still
craters
there?
within craters.
That's cool. Every year for the past 5 years, I think they've done this astronomy days at the museum here in Raleigh, and they do this really cool experiment where they take, I think they take cocoa powder on the bottom of this giant bin. They just layer this whole bin with cocoa powder, and then on top of it they put like flour or talcum powder or something, so it creates these layers, and then they let the kids take golf balls. And the kids are allowed to drop, or most of them, like mine, will throw the golf balls into this mixture here. And it's interesting because it does essentially what the moon does, right? Where you can see the rays kind of pop out and the cocoa powder goes flying all over.
Yeah, one of the other ways to do it is with powdered sugar and cocoa, and then use gumdrops. And then you get a fully edible thing. Another thing that you can do is if you want to simulate the process of creating regolith. Regolith is the dusty surface of the moon. Moon dust is insidious. It was apparently the thing that annoyed the astronauts most because there was nothing you could do to get the dust off of everything. And the lunar dust is created by this constant bombardment of micrometeorites on the surface that are just blasting apart all of the crust. So all of the rock, all of the gravel, everything on the surface is getting pulverized into this sharp, glassy dust. And to simulate that formation, what you do is you take and put a layer of graham crackers, and I think you put it on top of another layer. I don't remember. It may be a combination of Oreos and graham crackers. I don't remember the details.
Now I'm cold and hungry. Thanks.
Okay. Well, then you take gumballs because they're good and solid, and you hurl the gumballs down on the graham crackers, and you make regolith. That's
cool. Delicious.
And we will be posting all of those recipes for lunar simulations on CosmoQuest in about a month.
Really? That's cool.
Yeah, I have teachers working on designing all of the full curriculum that we're going to be posting.
Neat.
So what's neat is when you see the craters inside of other craters, the ones on the inside formed later. So you can actually see which crater is older than which crater. And when you see a big crater with no craters inside, that means it's young because nothing's had the chance to hit it yet.
There was an amateur in the past couple of years that actually imaged something. I would imagine nobody really knew what it was, hitting one of the darker areas, and you could actually see a bright blast.
Yeah, that happens occasionally. And one of the projects, the LAMP mission, it's a lunar atmospheric something that I should know. The LAMP mission is going to, or the LAMP instrument is going to be looking for changes in the atmosphere that are caused by something hitting the surface and throwing dust up. And it takes forever because the gravity is so high. It takes forever for the dust to settle back down. So it can create a measurable effect.
I'm going to leave my feet up here and go warm up for a minute.
Okay.
And then I will check back in a few.
Okay, and I will reload and look for more questions.
I think we probably want to wrap it up pretty quick at this point. I think we're film like from exposure. Again, I mean, we were just mucking around. You know how I roll.
Yeah.
He was just mucking around, and he was like, "Here, check this." He invited me to a hangout, and he's like, "Oh, take a look at this." And I was just like, "Yes, let's get that right now." Right. Because it was beyond my wildest imaginings. It's just gorgeous. I mean, this is so crisp and clear. I mean, I think if we're going to try and get, I mean, this is it for Saturn, Venus, Mars, Jupiter, the Moon, some solar observing. I think this gives us everything that we need.
I have to admit, I ordered my copy of the Observer's Handbook for 2012 from Sky and Telescope so that we can keep track of all the cool events.
Right, right. I think, you know, if we can do, you know, the Venus transit for sure. It would also be really, and then I think we're going to need to come up with some kind of technical solution for some of the fainter objects, like better tracking and like some kind of like maybe a 30-second exposure. So instead of it being in real time the way this one is,
Yeah.
have one that's, you know, pretty nicely positioned and updates itself every.
Well, and there's also some cameras that the way they do is they stack and output simultaneously. So what you get to do is see the picture grow over time. I believe some of the Meade cameras do that. What we really need to do is find one of the amateurs who has a 30-inch telescope.
Yeah, I mean, I
so
think
if any of you know them,
with able to also stream their footage directly into the Hangout.
yeah.
There's a thing called the Night Sky Network, and there's about 300 astronomers that are doing live streaming into their own footage in sort of live on the internet, and you can kind of be a member and join and check it out. But you know, if any of them would want to participate in this, that would be great. I mean, we've got Mike and we've got Sabine, and I'm sure Mike Solway, and once we can get John Chumak organized, and I talked to Tom Davis, and he said he'd be interested, but he's taken apart his whole observatory. But I mean, he's got the right setup. I mean, he's got one of these monster SUV-priced, you know, Takahashi telescopes with a ridiculous mount that he.
Someone asked in the feed, Eric Hampshire asked, "Oh wait, can we see Grail Pass? That would be so cool." No. One of the big problems is Moon big, Grail small. And so the missions, they're like the size of a Volkswagen, and you just can't see something that small at that distance. So we're out of luck. It could pass through the field, and we would absolutely never, ever know.
No. No. I mean, even the Hubble Space Telescope pointed at the moon wouldn't be able to see them.
Yeah, so it's like you can't see a goose if it's at the altitude of a 747 that's cruising overhead. You can see the 747, but it still looks pretty tiny. Goose, not going to be seen.
Yeah, I mean, these craters that we're seeing, many of them are dozens, if not hundreds of kilometers across.
These are dozens of kilometers across.
I said hundreds. This is the one underneath. I'm sure there's a big one there. We've seen some big ones.
Yeah.
But yeah, dozens of kilometers across. Craters within craters within craters.
Now what's cool is if you go to the Lunar Reconnaissance Orbiter data, when you view it full resolution, this is a spacecraft that's orbiting the moon and has amazing cameras on it. The Lunar Reconnaissance Orbiter images, the high-res ones, are such that if a fairly tall male were to lie down on the moon and assume the snow angel position, we'd be able to see them as something that would be several pixels in size. Not resolved, but there would be a splotch that's like 2 pixels wide and 3 pixels long or something.
Chad Gray asked in the chat, what scope and camera is being used? It's an 8-inch Celestron, so C8, with a webcam velcroed on to the eyepiece. So that's how we're seeing this.
And the webcam has had the lens and the IR filter removed. The problem with the lenses is they make the cameras focus on things nearby, and the light coming in from the telescope is focused at infinity.
And Elizabeth Mitchell said that she doesn't have a 30-inch scope, but she does have an 8-inch with the DSI camera. Elizabeth, yeah, I mean, if you can, I mean, all we need is more people who can somehow get a live stream from their telescope into Google Hangouts. I mean, that was the trick that this was Mike's great accomplishment, was that he was able to somehow get a live stream from his, you know, that telescope into the webcam, and then from the webcam into his computer, and have that be part of the Hangout. So, you know, really, if anyone else wants to participate in this, my dream is to have these 3-4 telescopes all going at the same time, showing different kinds of quality, pointing at different objects, and we'll just, you know, we'll take this as far as we can. Timmy Rao asked, does anyone see the pic online of the ISS with the moon? Yeah.
Yeah.
It's a beautiful view of the moon, the International Space Station, just up in the corner. One of the coolest services on the internet is this the ISS, Twitter ISS notification. Anyway, it's Twist, so it's TWISST, and if you follow that user on Twitter, they will send you a update when the International Space Station is going to fly above your location. And so when you do that, you just take a look up. Literally, it says, ISS will be out at 5:15. Will be a very bright pass. And then at 5:15, you go outside, you look, and sure enough, this bright star, brighter than anything else that you see, brighter than Jupiter, brighter than Venus, goes...
The Iridium satellites are brighter, but
are
they're
they
falling out of the sky nowadays.
Yeah, briefly. But yeah, and it's just amazing to see that.
$1 million junk?
Oh, so
The Iridium satellites?
Yeah.
Yeah. And actually a complete bane on the existence of radio astronomers.
Really?
Yeah, so one of the problems was there's actually an international treaty that set aside certain wavelengths of light, and radio is just a wavelength of light, and said that those were protected bands that could only be used in detection mode by radio telescopes, essentially. So no broadcasting at all in those bands. And Motorola, when it launched the Iridium satellites, at least I think it was Motorola. I might have that wrong. I'm working from memory here. When the satellites were launched, they broadcast for satellite phones in those protected bands. And the satellites, of course, passed right over Arecibo Observatory in Puerto Rico, just making it impossible to take data. They did eventually work out a deal where the satellites would stop when they were over Puerto Rico and other protected sites. But it's still something that shouldn't have happened. But the decision was basically made of, once we get them in orbit, who can stop us? And it was true.
Tim Rowe, I apologize. Tim Rowe. Got it. Sorry. And Christian, we apologize for keeping you up.
I think this is Copernicus here, isn't it?
It's looking familiar. I do not do creator names real well, but I do Google real well, so let me verify.
I dare not go to Google Moon. This is the big mistake that we made yesterday.
Really?
Yeah. If I go to Google Moon, this whole show is over. It crashed my plugin, my Hangout plugin, and the whole thing just shut down.
Yeah, luckily I was going to Google image search instead, so we were doing fine. Now I just need to find one that is the correct angle. Yes, you have rediscovered Copernicus crater. And this is one of the ones that has one of those central peaks that I don't remember what caused. Let me go to the wiki page.
It almost looks, because it fades in and out, it almost looks like there's two peaks there.
Yeah, there are. Well, it's not that there's two peaks, it's that there's a central group of splashes.
Ah. I like the real marbly texture here. There's real white areas, there's gray areas, and then there's dark areas kind of up around the 1 and 2 o'clock position. In the upper
How's
right.
everyone's time doing? Because I know you're starting to freeze solid out there. We're worried about...
I am.
Yeah, we want to make sure that you can do another one of these, Mike.
Yeah.
If we kill you off in our first attempt, I think that that doesn't. But we can't kill the golden goose yet.
No, I'm pretty hardcore. I came out the other night for the meteor shower, just me and the blanket, and it was about 18 or 19 degrees, and I stayed out for a good half an hour. I didn't see but one meteor though.
Oh.
None.
Yeah, I was a little disappointed. I didn't stay out that late. It was supposed to peak around 2:30 local time. I don't think I was out till 10 or 11. So probably not late enough. But I don't know. Was the show any good anywhere else?
I haven't heard any big wow from anyone.
Yeah.
So one of the reasons that this is such a famous named crater, or was before it disappeared, is when you look at it, you can actually see this blanket of rayed material going away from the crater. And then it has this terraced rim going down into it. And that blanket of material is actually the lighter colored material that got splashed out while the crater was forming. This crater was formed about 800 million years ago, we think, so it's fairly young.
Well, as we're talking about it, let's get it back. Is that it?
So you can see that blanket extending away into the darker material.
By the way.
Now I'm going to look up what causes central peaks and craters. So if you don't know, the Lunar and Planetary Institute actually has a ton of really awesome stuff on the moon. And they have a My Moon website, which is, I think, one of the coolest designs for trying to inspire teenagers to care about the moon.
All right. Well, I'm going to have to roll because it's time to get the kids to bed, and I think we've been running for a long time. I have a feeling we're going to break Google at this point. And
Yeah.
so, Mike, thank you very much for getting
Yes.
this out. This is just amazing, and you have sort of succeeded to beyond our wildest expectations. You've helped Celestron sell a telescope, and I think you've given a lot of people a really great view, one that maybe they've never even seen with their own eyes live through a telescope. So I think we're all really grateful. And if people haven't seen anything yet, I mean, again, we are still just running experiments, getting this figured out. You know, at some point when we've got multiple telescopes, we will then put on the show when we can actually look at different objects and talk about them and explain them, and I think people will really enjoy that. So, and especially, you know, if we can move up to your 14-inch, please. That would be
If the
awesome.
weather holds, I'll try around this same time tomorrow. When did we start? About an hour or two ago?
Yeah.
Okay.
About 6:30. But you know, no pressure. But this is phenomenal. I mean, this will,
Cool.
you know, these views of the moon and Jupiter, and I know when we see Saturn, it'll blow people's minds. So that's just fantastic.
Well, I hope everybody enjoyed it, because I know I did.
Good. Yeah, absolutely. All right, I'm going to shut down the broadcast, but thank you everyone for watching, and thank you, Pamela and Mike, for showing up. That's amazing.
Oh yeah. Bye everybody.
Thank you.
Thanks.
Bye.
Bye-bye.